I want to talk about this problem. 6.2 young Americans, about 77% of young adults think they can achieve the American dream. Determine if the following statements are true or false and explain your reasoning. The distribution of sample proportion of young adults who think they can achieve the American dream is left skewed. So let's take a look at that. Here is my pictures, right? If we were to have no skew, we would expect to have the proportion to be right in the middle, right? Here would be about 0, and here would be 100, and right in the middle is 50%, right? But in this problem, and let me zoom in a little bit. In this problem, we already know that the proportion is 0.77. So when we have a relatively small sample, we're to the proportion is to the right of the middle. This being the middle. And so most of our data is in here. Most of the young adults think they can achieve the American dream is like in this clump. And so less adults that think they can, there are less adults that think they can achieve the American dream over here. So we would say this is a left skew. As our samples get bigger, this thing becomes more normal and we get less skew. Less skew, not left skew. But our sample size is 20, so we're going to have a pretty hefty skew. And so this is kind of how we can think about that for part A. Let's go ahead and take a look at part B. Part B, boop, boop. There we go. Distribution of sample proportions of young Americans who think they can achieve the American dream in sample size 40 is approximately normal since n is greater than 30. So this is a tricky question because the rule of thumb is if you have a sample of size 30, let me go ahead and get back to my really cool whiteboard here. If you have a sample of size 30, then your distribution will be roughly normal. That's the rule of thumb. So anything greater than 30 would give you a roughly normal distribution. But that's not always true. And the way that we can test this is we can do that same test that we were doing in our project where you have to check for normality. You do n times p, and you do n times p minus 1, right? So n times p here, remember what these have to be. These both have to be bigger than 10. And if they are bigger than 10, then it will be roughly normal. So what is n? N is 40. We know what p is. P is 77, 0.77, and this is 40, and this is 0.23, right? So if I multiply those together, let me go ahead and do that. I'm going to pause this. I'm able to pull up my calculator. Oh my goodness, 0.77 times 40. That seems okay. So that's 0.38. So I'll write that here. Oh, sorry, what am I talking about? 30.8. And then what's the other one? We got 0.23 times 40. And then this is where the problem is, right? So it's 0.92. Or sorry, 9.2. So this value here is not bigger than 10. So this thing is not quite normal. So not quite. So yeah, so we try to check for normality, and we got it, that it's not quite normal. Just doing this computation here. So what would that be? The distribution of sample proportions of young Americans who think they can achieve the American dream. Sample size of 40 is approximately normal. We would say that's false. Okay. A random sample of 60 young Americans where 85% think they can achieve the American dream would be considered unusual. Let's take a second and think about that. Like this is 77%. So if I went out and I sampled 60 people, and I would expect those 60 people to have a proportion that's pretty close to 77%, right? Like 78% would be fine. 80% would probably be okay, but then the question is like, is 85 too far away? And so what we can do is we can actually, we have to decide what is unusual. So maybe we'll make a 99% confidence interval. Yep, we'll make a 99% confidence interval around 77. We could do that. And if it includes 85, then we're like, oh, that's fine. And if it doesn't include 85, then maybe that feels weird for us. So let's go ahead and do that. I'm going to pause it real quick so I can set up my confidence interval here. Okay, so I was going to do sub a hand, and then I realized I could just use my Google Sheets calculator and make my life easy. So I'm in the confidence intervals tab, um, and I can actually zoom in on this a little bit. There we go. That's pretty good. So now n is equal to 60, right? Our p hat was, oh, we should probably think about this in a different way. Why don't we make our p hat 85? We'll do that. We'll make a confidence interval around 85 instead. And we'll do confidence level of 99%. If it falls outside of that, maybe that's unusual. Unusual is kind of ambiguous. It could be 95%. Maybe we'll play around with them a little bit. Anywho, if I do a 95% confidence interval around my population, my sample proportion of 85%, I get 75 to 94. And notice is our actual proportion in there? Is our actual proportion was our actual proportion? If only I could click the right thing. Oh, it's up here. Our actual proportion is 77%. So even in the 95% confidence interval, it's in there. So it does not, because 77% falls in our confidence interval, it doesn't seem unusual, right? Remember what we're doing when we're making a confidence interval. We are trying to capture the true population proportion. And I have captured the true population proportion because for this problem, I just happen to know it. So it is not unusual. If you disagree, if you're like 95%, what about a 90% confidence interval? That would make it more unusual. Well, then that's weird. Then we'd have to. The problem is we have to agree with what unusual actually means. And with a 90% confidence interval, there's a 10% chance of not getting your true proportion. 10% is pretty big, so I think that would not actually qualify as unusual. The 99% sounds even better. Then there's only 1% chance of missing it, and here we definitely have the true proportion. All right, okay. Let's go ahead and do the next question. Part D. Part D. Part D. A random sample of 120 young Americans where 85% think they can achieve the American dream would be considered unusual. Oh, so let's go back and look at this again. Now my sample is not this. It is 120, right? My p hat is the same, and I'm still using the same confidence level of 99%. And here we are still capturing the true proportion. Yeah, that seems fine. Except now, as if it's 95. What if we make a 95 confidence level? Then we're not capturing the true proportion anymore. So once again, we have to like agree with what unusual means, right? Like if we have a 95% confidence interval, that means we have a 5% chance of not capturing the true proportion. Here we did not capture the true proportion. So was that just by chance, um, or is our true proportion actually wrong, right? I wonder what the MyOpenMath thinks is unusual. Let me open up my problem. Let me pause this again. So I'm going back over here. So I would have said that so at the 95% confidence level, we didn't capture a true proportion. So that would make this thing seem unusual. So I would say that's true. And it says true. So, and at the 99% or the 99 confidence level, 99% confidence level, we did capture a true proportion. So then I would have said it's false. So this wording is unusual is maybe too ambiguous. Like, do they want a 99% confidence level or a 95%? Here, they clearly want a 95%. That's what they're defining as unusual. I don't know. I don't know if you agree with that definition of unusual. You can decide. Uh, it doesn't matter as long as we understand like why we're saying true for the 99% confidence level and false for the 95% confidence level. All right, I hope I have explained those enough. If not, feel free to post and I'll try again. All right, let's go ahead and pause this. So go ahead and finish.